Thanks a lot for being here, and this is the Microsoft Azure Security on part of Informator. My name is Sasha, and I'm an Azure MVP as well as the MCT Microsoft Certified Training for more than 15 years, and also certified EC-Council Instructor, but also specializing in Azure, cloud and security and multi-cloud solutions, Azure, AWS, and Google Cloud Platform as well. So, in fact, this one is our session is in fact talks about Azure network security, but let's talk first about a few introductory terms. The Azure network security is only one part of the Azure network of Azure security. So Azure, as every cloud provider, actually provides a layer approach and multiple layers of protection. And as we see on the slide, this is just one part of securing overall Azure infrastructure or your cloud infrastructure. So this is just one, let's say, one drop in a sea, and it's just one part, but it's a very important part. I wouldn't give any preference to any security layer that we see here, but in fact, what we see is the term defense in depth or overall security or the security as a layered approach, where the network is only one part, equally as important as the other ones. So we shouldn't make any part of our infrastructure or organizational security weak by not focusing enough on it. But because everything that we do security-wise builds on top of each other solutions, and in fact take into account, actually is taken into account and added, and all these solutions that we implement actually bring final, let's say, final security posture of our infrastructure of our organization that should be as high as possible. So that that begins with the physical security. We fortunately today we don't bother, we don't take care about physical security anymore, because if in the cloud era, of course, that's taken care of by cloud provider, in this case by Microsoft. But we still do have to take care specifically of other things like identity access and perimeter and compute application and so on, and data. But in here we are in fact just focusing on one layer, and that is in fact the network layer, and the network security. Well, we will in fact talk about all these things here, and these are the network security groups or application security groups, and other things that we'll mention. So there are a lot of them. So this is just one part, but I think it's a very critical and crucial part, because it has direct implication on how we work. This is in fact the network security is in fact the one that most of the people and most of the IT admins, most of the companies have immediate access to, or well, not access to, but it's the first impact that we have along with the compute. The network is one that should be in place before actually we deal with the compute. So, for example, if we want to connect some virtual machines, then we should have already a virtual network in place. I mean, of course we can provision network at the same time as we provision virtual machines, but anyway, in corporate workloads or in a corporate architecture, we would probably have networks already in place, and we will have also network design with different segments, subnets, etc., etc. So this is something that actually is forming the base of our security. But I must say once again, this is just one part of a whole defense in-depth strategy that you should adopt, and that is since security is not just one big switch where you go and pull the lever or press the button, and there we have a secure environment. But in fact, security is reached, and correct security, high security posture is reached by implementing every security best practice and step at all layers, so the data, application, compute, network, and others as well. But let's first see what we have, and then we will also take a look at the portal and see what we have. In fact, the first thing we have is well, of course, we have we'll talk about Azure security, network security features, but everything in fact begins with correct architecture and with correct design before we actually even have the chance to configure network security groups. We will have to think about the layouts, the architecture of the design of our virtual networks, which have to include the correct subnetting, correct names. Of course, very important is the naming convention and tagging convention as well. So that's something that should be implemented in the first place before we actually even deploy networks. So don't forget, naming conventions and tagging conventions. Each of our resources should have tags, and that should be, for example, enforced by using Azure policies, if nothing else. Typically, when we deploy a resource, and if we don't set a tag on a resource, then probably we will never do that again, and we will forget. Usually administrators forget or don't bother or have other things to do, and the tagging is something that is usually the last thing on their mind, but in fact shouldn't be. First of all, we live in an era where we have cloud computing available, where we have the agility and possibility to provision something in a few seconds and delete in a few seconds. And a lot of admins say, okay, well, if I forget something or if I actually do something wrong, then I will just delete and provision again, because it takes a couple of seconds to provision the virtual network or any kind of resource, mostly in a couple of minutes. Yes, that is true, but that is not true if the things change. If you, for example, if the things change when we have these resources when these resources actually are in working scenario. So if we have a production, if resources go in production, then these are not so easy to delete. First of all, we don't have a rename function in Azure. So if we create a resource group or network or a compute resource with the wrong name, or some not so obvious name, or some names that are not correct, we won't be able to rename them. And the second part is if these resources are placed in a production tomorrow, then it's very hard to delete them and redeploy them in a correct way, meaning giving them correct names and placing in designing them in a correct architecture type way, without introducing a possible interruption in production. So that's very hard. And we were in the past, we were thinking about, of course, we weren't thinking about that in the past, but we still have to 80% do 80% of planning and 20% of execution. So planning, especially in cloud area in Azure, it's very important because we will have less problems there. So naming convention is very important because for scripting, for identifying correct names, the naming convention should be implemented correctly. As for example, if you look at your ceiling, or if you look at your electrical installations, electrical engineers and HVAC, cooling, or for example fire installations have all these code names where they are easy to identify. For example, when the electrical engineer goes to the fuse box in the basement, then he immediately or she knows that a certain fuse or part or switch actually belongs to a certain plug or network outlet and so on. So that should be the same thing that we do here. So once we've done that, and once we deployed it, we have network security groups, which are in fact the first part to secure our, besides of course the correct subnetting portion and design, to control the traffic in and out of the virtual network. In fact, we can attach a network security group, which is the NSG, to either subnet or to the network interface card. So we have two possibilities. These are used to control and limit network traffic. As I mentioned, these can be associated to the subnet or network interface, so we can do both. We of course can do none and not associated at all, but this is not the best practice not to have network security group. And we use a network security group use rules to either allow or deny network traffic. So actually, we use of course we use the security rules, but of course if we don't have a rule, then the traffic will be of course denied by default. And we have two types of rules. We have actually inbound and outbound rules that also have some default settings as well. So while we can attach them independently, we can attach them to the like I mentioned, to the network security group, to the network interface, or we can attach them to the subnet level. We need to think about implementation as a little bit more carefully, since allow rule must exist on both levels for traffic to be admitted. So what does it mean? So for example, in this case, if we have network security group 2 that is actually attached to the to this network interface card 1, and if we have network security group 1 that is attached at the subnet level, both of these network security groups 1 and 2 have to allow rule, in fact, to allow traffic to go in. So if the network security group or 2 or 1 has one rule that actually forbids traffic to go in, the traffic won't go in. This is one nice implementation where some administrators actually suggest that we should have either 1 or 2, either first or second implementation. So either that we should either have network security groups implemented on the subnet level or at the network interface card level. I would say that we should take a leap forward and add a little bit of administrative, let's say, administrative burden. Well, it's just not a burden, but actually it's a best practice, in fact. And I suggest that you have both. Why? If you have both, then you can selectively, if you have, for example, in some cases, if you have multiple virtual machines in there, So you can, let's say, for example, if network security group 1, if there is virtual machine 1 that actually has to have rule 1, and virtual machine 2 has to have rule 2 and 3, for example, available. So I won't write port numbers to save space a little bit. Then we can set up the network security group that is on the subnet level to allow 1, 2, and 3. So ports 1, 2, and 3, and nothing else. Then selectively on the network interface card level, we can say, okay, virtual machine 1 will be allowed only this traffic, and virtual machine 2 will be allowed only this traffic. This way we achieve 2 parts. So two things. We actually forbid any traffic other than ports 1 to 3 to go in the subnet. And then we additionally secured virtual machine 1 and 2 so that virtual machine 1 doesn't get traffic on 2 and 3 ports, and virtual machine 2 that doesn't get the traffic on ports 1. So we have additional security as well should something go wrong. So it might look like an overkill, but in fact I suggest, well, I think it's not, because we've seen a lot of implementations where admins and design actually presume that something is not valuable or not valid, or that we shouldn't have any such an implementation. But then turned out that that was in fact the problem, because they didn't have such a layered protection, and when the breach actually occurred, or some ransomware hit, or some as we've encountered many companies they've suffered losses. In fact, the things happen, and the bad things happen, unfortunately, and we should implement security and enforce security wherever, whenever we have the opportunity to do so. We can then, of course, add additional protection by implementing application security groups, and this is in fact a similar thing as well, application security groups can be used in network security groups rules, and that's where we in fact group our servers, for example, or virtual machines or computers, let's say, and add them to a application security group. And after that, we define the application security group in a rule, and just once, and then we are able to control with that one rule inbound and outbound traffic for the specific application security group. Hence, if we have any virtual machine that also is a part of the specific group, for example, like in this case, we have NSG1, or application security group that is consisted of 3 servers. If we need to add additional 3, we just need to add them to the application security group, and not to the and we don't have to define any additional rules on network security groups for that case. So when we deassociate the particular server or computer from application security group, it automatically loses the benefits of receiving or sending traffic for what has been defined. So in fact, let's take a look. One example. So we have virtual machine. Well, first of all, let's go to home. We have to have application security groups defined, for example. Application security groups is defined very easily. So we just create let's say a container. and that's the application security group. Actually, that's the metadata that will actually be tied to the server. So if we go to one inside, let's say, there's nothing much to see because we have properties and logs and other default things that that is usually in here. But then what happens when we go to the virtual machines, let's say, and let's take a look at Arc Server 1, for example. When we go to networking, that that Arc Server has one network interface, and that Arc Server has attached the network security group, this one. So this has its own IP configuration. It has virtual network subnet, that is this one, and then it is attached to the it has this network interface card. And then we have inbound, well, actually, there we have network security group Arc Server 1 NSG that is attached to subnet. The subnet name is default. And then we have also this one that is attached to the, well, we see the information in here. And this is also applicable to the outbound security rules. What else do we have? We have a tab that shows the application security groups. And each server can be in one or more or none application security groups. And this one is placed in 3. And we can configure the application security groups. For example, let's take this one that doesn't have so much security groups. We can configure the application security groups and, in fact, pick the application security group that we want this server to actually this network interface to be part of. Here we see that Azure portal actually has some rendering issues or some alignment issues where we have our text, in fact, overlapping with the checkboxes, and I hope Microsoft will correct this very soon. So, for example, servers. And once we do that, we can do one or more, of course. So service, clients, and so on. Let's say put it on backhand as well, and then click on save. What have we done now? We have done now the following thing. Let's wait for update, and in fact, there it is. I will just jump to this one because I have already defined some application security groups in here. So what we do when we define the application security, well, when we define the inbound port rules or outbound port rules, then we also can reference application security group as a destination, for example, in a specific rule. So you imagine that any server that belongs to that group, also this rule 310 or 320 or 330, whatever it is, also applies to the servers that are part of these groups. So if we detach the server, the virtual server here, virtual machine from this application security group, then this rule, for example, won't apply to the specific server. And then that's a very nice way how we can, in fact, control traffic. And then we have also this network security group. Let's take a look at one where we have inbound security rules, which is the list here and here. And in fact, we have this already on an overview page as one list. As well, we have the associated, well, not associated, but we have a list of network interfaces associated with this network security group and subnets, or vice versa, where the network security group is associated with these subnets that are listed here, or network interfaces. So we can see that it's just one. But in fact, what we have default rules. So if we don't have any rules here, by default, the traffic in the virtual network will be allowed by, of course, it's needed by services as well. We have the default one where this is the one that allows traffic from load balancer, if of course very needed if we have any resources that allow a virtual load balancer, Azure load balancer. And then after that, everything is denied. So unless we explicitly allow traffic to go through, then it won't, as well as it won't go out as well. And here we have the information and of course some also visual clues that we shouldn't have these ports open. Well, I have this deliberately open to test these servers, but actually we can see the network security groups actually rules that can be these default can be hidden, but we can in fact add an inbound security rule as well as the outbound in the same way. So this is the layer 4, and the TCP and UDP are supported, as well as the ICMP as well. 2 actions, allow and deny. And then we have source and destination port. So the asterisk, of course, means any port is referenced. As well, we can set a destination and source any IP address, for example, any service tag. Service tag can be any service tag that is here, for example, the generic ones that is internet or virtual network, for example, or load balancer and action group and so on, but other services too. And then we have also different application security group, and that's where we define our access to the application security groups or from these. So we have 3, like we've seen in a previous example, backend, clients, and servers, and then we can reference these, for example, and of course we can add different ones, let's say, and of course we can choose any destination, of course, and pick the port or service. Custom means we can make our custom ports, define our custom ports, or we can in fact choose the predefined here. So if we don't remember the exact port names, actually port numbers, then we can choose the appropriate names as well. And then we, in fact, what we do, we need to define the priority and actually name the rule. The rules shouldn't be like names all like this, or if they have short names, definitely I suggest that you add description whenever you can. Why you did this and what does it mean, why this rule is here, what purpose does it serve, and so on, because administrators come and go, change companies, change positions and everything. So if someone adds actually here some rule, then in 2 weeks and imagine in 1 year, no one will actually know what does it mean and what it is for. This is very easy here because we have like 4 rules, and it's a small environment, but imagine the production environment where some of the companies I worked for have like 4, 3, 5, 7,000 virtual machines, and with a couple of thousands of network security groups and hundreds of rules inbound and outbound, and plus the firewalls and everything. So it's of utmost importance that we place a description here as well. And one thing also we should mention then, there is the priority that will go from 100 to 65,000, and some IT admins have the practice to distance the priorities and name them in hundreds, so or in 50s. So or in tens if you have more rules to make. In fact, this is important. So if you need to make any rule afterwards or insert in between, then in this case you will have a little bit more space and space for future expansion or future things to change. So, but I suggest that you go in hundreds or in 50s if you really have to go with a smaller number, and then try to, if you insert in between 50s, then go with tens, so it will be much more clear. So always leave space between these rules. This is in short in fact the network security groups and application security groups, and then we have other things to mention as well. So what we also have, we have service endpoints, and these service endpoints actually limit network access to specific subnets and IP addresses from specific to specific service resources. And in fact, these endpoints use Azure Backbone Network, which is actually very secure and simple to set. These service endpoints are actually give us the possibility to additionally secure access from, let's say, like in this case, from a virtual machine to the storage account in this case, or we can use any of others that are available, like Key Vault databases and so on. But let's take a look at this one. So let's take, in fact, as we speak, as we are here with this Arc server, let's take our Arc server to actually configure this and make it more secure. Let's see the configuration, what we have here. Yes, of course, we have the just-in-time also, but if we have the possibility, if we have the Microsoft Defender for Cloud plan that allows the just-in-time, then we will also be able to also control how these RDP ports are opened. So just-in-time access automatically controls the placement of network security groups. What else do we have? We have, in fact, let's take a look at the storage or at the Key Vault, and how can we in fact give the secure access to our resources. In fact, let's take a look at the resource groups, and then we have storage, for example. Let's pick one in this case, and that would be this one. So we have blob storage X, for example, and then we have in fact networking. And in the networking part, then we will see a couple of things. We will see firewalls and virtual networks. In this case, we will this blob storage account actually has access. Well, we are allowed to access this storage account from all networks. But if we want to select only specific networks to access this storage account, in this case, like this one, so we want to access this storage account only from this virtual network or from this subnet. So then we will, in fact, either add the new virtual network if we don't have one, or add an existing virtual network, so we can in a secure way in fact limit the access only to these virtual networks to that, for example, storage account, let's say. So if we click on add existing virtual network, then we have to choose the subscription. Then of course we have the, let's say, if we have the virtual machines that are in the North European, let's say this virtual network, and I'll click this one, and then afterwards I'll select the subnets that are available in this virtual network, and this one is one that is available. So research subnets. So I won't use these because these are reserved subnets for application gateway, for firewalls, and for gateway. So this one is available. Although I would be able to do that as well, but well, not this is not actually something that is advised to do. So research subnet is the one that needs to access this storage in a secure way. And then what we will actually do, we will in fact see that VNet Nord EUC2 and research subnet actually will have service endpoint status enabled. So if we take a look at the VNet Nord EUC2, let's actually take a look at this one and then networks quickly. And let's take a look at the virtual networks. Then we will see the storage account, actually virtual networks. What was it? This one was the VNet Nord EUC2, and this is VNet Nord EUC2. Yes, this is the one. Then we will see, in fact, that we have these subnets, and in fact, we have research subnet that, in fact, has the service endpoint defined. So it is defined as a service endpoint. We have status succeeded, and we can in fact see that status here is enabled, and then it's active, and here as well. So, and we can also, for example, if we have any policies associated with the policy, but still this in fact storage account will only allow access from research subnet. So, and if we have our virtual machine placed on the research subnet, and or for example this one subnet, and this virtual machines or any virtual machine from the machines from different subnets want to access the storage account, they won't be able to do so because we limited this to the research subnet. And in fact, we also made this connection very secure in a private way as well. So I'll in fact delete this one in fact and remove it, for example, before we do that actually. And since I want to, and in fact not to limit this to any virtual network, let's say if I go to the virtual networks, let's just see if it's still there, and Nord EU, and then we have the subnets, and then research one, and then yes, it is still here, but we can delete it and apply. Anyway, it is a very secure way to do that. And what else do we have? We also have the private endpoint too. The private endpoint, in fact, uses the private connectivity to services to Azure. And instead of going to over the internet and actually establishing the public access, the traffic actually, when we set a private endpoint, the traffic remains on Microsoft network with no public internet access whatsoever. So that's in fact very important part. So instead of publishing this endpoint to the let's say storage, for example, let's take a virtual endpoint, let's say actually private endpoint. We've seen also that one. So if we want, let's take a look at where's the storage? Oh, there it is, blob storage. We can use that. So if we go to the networking, then we also have a private endpoint connections. So we have this private endpoint connection. We can also use that. We can also use that one, and it is automatically approved since it's on the same network. In fact, and these private endpoints has to be defined. For example, we can create one very easily. Let's see the one that is in fact here, and actually let's take a create and see what we have. So I'll just pick randomly here just to see the options. We choose the, yes, of course, that's one. We choose the resource for which we create a private endpoint. That will be, for example, let's say, or any resource type here. So whether it's storage, compute, actually storage. So we define the storage account, and then actually we publish the endpoint. And after we create an endpoint, what we need to do, we need to also establish the. We also have the possibility to establish the private link. So anyone with a private link will actually will be able to connect in a secure way, for example, and private link 1 to the endpoint that we've published, and of course we define also the way how to the connections are going to be established, and after that we're able to access the endpoint. What else do we have in terms of security? We have also very nice Azure Application Gateway, the Azure Application Gateway, or Web Application Firewall. In fact, actually, it's a similar. Well, it's a layer 7 appliance that actually has a lot of options for load balancing and protecting the content. So first of all, it's similar as load balancer, which in fact works on layer 4. A bit of excellent. There it is. The load balancer in fact works on layer 4. And on the other hand, this appliance, Azure Application Gateway, works on layer 7. It is used to load balance and forward actually the layer 7 traffic, typically HTTP, HTTPS traffic, where we have, first of all, we have also the possibility to include Web Application Firewall. We have 2 generations. Once we pick one generation, then we won't be able to change the generations. But we will be able to switch from the application gateway to the Web Application Firewall, which actually allows some very cool things. And this is the also allows us the SSL TLS termination. It allows us to host multiple sites and backend pools. It supports a lot of backend pools like application services, scale sets, VMs, and some on-premises external app servers as well. So how does it work? It has also some other very nice things like URL-based or path-based redirection, in fact, session affinity, and so on. So especially effective if we had any, let's say, sessions running on in the background. If we have, of course, disconnected users, then these can effectively connect to the same endpoint. And then there we have a listener, of course, like with the load balancer. We have a rule, and we have also the configuration for the front end and back end, and where we also have the rules. These rules actually determine how the traffic will be in fact redirected. And we can also turn on the Web Application Firewall, which actually is supported in other network security solutions, for example, like in a front door and so on, and in Azure Application Gateway, etc., as well as in the previous in the CDN, in fact. But this works on actually works on the OS core rule sets, the recent 3.1. And it can, in fact, actually protect from different attacks or misconfiguration, for example, like cross-site scripting or SQL injection, and etc. But let's take a look at one that we have in here. A few things to go through. For example, here is WAF, in fact, or the Web Application Firewall, actually, the App Gateway. We have one, and then we have also the gateway policy too. So what application gateway is consisted of? Well, we have several things. We have config. Well, we have actually see the properties. In fact, let me see that. Oh, yes, let's take a look at the configuration, in fact. So we have a tier, currently is works in a web application firewall mode, and since we have V2, we can only switch between app gateway and WAF. Second generation, we can't skip the generation. We have also possibility to have multiple instances as well as to enable disable HTTP2. And once we've done that, we have application firewall settings, which in fact has to be associated with the web application firewall policy, which in fact in turn control how the application gateway works. So we have different rules, and the custom ones, the OS rules. So this is the managed rule set. The 3.2 is one in a preview, and then we have custom rules as well. We can in fact add any custom rule, and of course we have the associated application gateway, since the policy can control multiple gateways. But let's take a step back, in fact, to the WAF or web application firewall. We need front end first. The front end can be is configured here. We have two front ends. We have public and private. The public is configured with, in fact, as we deploy the application firewall. Actually, the WAF we defined the front end, and once we've done it, we define also the backend. The backend pool, we have only one pool with two targets, which is in fact we have two virtual machines, but we can add more. We can add any IP address or FQDN, VMs, virtual machine scale sets, app services, and so on and so on. And then of course we have we can set any of these. And once we set up the backend pool, then we have also we have other things. We have HTTP settings for the pool. So HTTP settings determine the backend port, the protocol, and we also determine the additional settings, for example, like cookie-based affinities and so on, or request timeouts. And what else? What we need to determine is, in fact, determine the listeners and rules and health pros. First of all, we have a listener that actually determines how the traffic will, in fact, the listening endpoint. The listening endpoint is, in fact, determining which ports are being used with specific front-end configuration. And plus, we have also the health probes. In fact, actually, we have the rules that are, in fact, routing rules that determine how the rules can be will be in fact processed. So we define the rule name, which is, in fact, I don't have one, but we can actually pick one from the list. And then we can also define the backend targets too. And once we've done that, we have also the health probes, which in fact determine the health of the backend services that we've defined in the backend pool. So what does it mean? It means that if any of probes here determine that the specific path or host is not available in these timings settings, it will automatically update internal routing table and actually forwarding table, not routing, and this forwarding table will not then include any of these unhealthy or unavailable backend pool members until they come online. And the polling continues despite that. The polling continues, and when the resource it's back online, then the forwarding table it's then updated again, and effectively we have the traffic that it's allowed to go in next. And then we have also what we have additionally, we have in fact other things, and these are this is the practically Azure Firewall, but Azure Firewall is not something, well, Azure Firewall probably won't classify as the Azure Network Protection. I would think it's, I would think of it probably like more of perimeter protection, for example, but still it deals with network traffic, and that's why I wanted to include it in here as well. And the Azure Firewall is a platform as a service, or I'd say firewall as a service where sorry, this one is entirely managed by it's managed managed by Microsoft, and it is integrated with Azure Monitor. It is integrated in Azure. It has automatic built-in high availability. What's in the back of Azure Firewall? In fact, you have in Azure Firewall, you have 2 virtual machines provisioned, and that's everything that you actually have. That's the only contact that you have with this virtual machine. The only contact that you have with this virtual machine is the possibility for your, for example, if you're testing Azure Firewall, to shut down these virtual machines using PowerShell command, so that you don't incur any cost, for example, in the testing when you test Azure Firewall, for example, and then you have to turn them on using PowerShell as well, because you don't have this option in the portal. But in fact, this Azure Firewall comes into flavors, let's say, or into SKUs, and in fact, where's my Azure Firewall? There it is here. The firewalls come into 2 options. We have standard and premium, and the standard, the premium can be managed only by policy, which is premium or standard policy, by premium policy. And the firewall manager, in fact, actually the standard manager can be managed on its own as a standalone one. But the premium can be only managed through the policy, because we have additional options with the premium one, which is the threat intelligence, TLS inspections, intrusion prevention, detection and prevention systems, and possibility, and so on. So of course, this policy is not the premium policy. That's hence this is why this is grayed out. But with firewalls, we have the possibility also to manage the firewalls with multiple firewalls with different policies, which can be standard and premium. And of course, these policies can be nested, in fact, and the firewall actually supports the network layer 4, layer 7, layer 3 rules and traffic management. So and then of course, similarly as with network security groups, we have different rules that are can be network rules for controlling layer 4 traffic, or applications rule for controlling layer 7 traffic, and so on. So for example, if we want to in fact add a rule let's say we can add any role collection and define any, for example, IP address or group, and determine the how this firewall works. And there is in fact there are a lot more services that actually determine that fall under Azure Network Security. Here are some characteristics of Azure Firewall, like supporting the FQDN tags or inbound or endbound network address translation. And then we have, for the last thing, we will just mention Azure Front Door, which actually is used to achieve layer 7 global routing. And actually, as the name implies, in the front door, we in fact, let me see if, yes, there we have 2 flavors, front doors as well. Oh, actually, there is not one, but nevertheless, we won't be able to connect to create any of these, in fact. But with the front door, we can in fact provide a different. It is one place, in fact, to provide resources to internal resources to the public in a secure way, including application firewall and so on. In fact, yes, demo. Well, but we actually had demos as we got along. And then I will have to give the word to my host and to close the presentation.
Here are some courses that we have in these related subjects, and it's in December, January, and all the way up into March. And if you have any questions, you can contact us at Informator, and we'll help you and set you right. We're also able to, of course, tailor make these courses for your company.